All right, here's our last example. I have a particle moving along the x-axis, and I have an expression for its velocity, v of t, and I have a graph of the velocity, and I know that at time 0, it's at x position 5. So that is not the position graph. If I made the position graph, this is time, at time 0, do a better job. At time 0, the position is 1, 2, 3, 4, 5. 5. Okay, so can I find the position of the particle at time t equals 3? Well, we will have a little bit easy. It's a good habit to build. They're asking me for x of 3. I'm going to not give x of 3 until I can write an expression for x of t. So I'm going to use what I just used in the last problem, what I'm calling the most important example in chapter 5, this idea. I have a function that I want to write, the position function, which I'm going to call x of t. And I know x prime, the derivative position, is supposed to be the velocity. And I know one ordered pair on the x function, and that's 0, 5. So I'm going to write a function, an x function, that has an integral in it. So here I go. I'm going to write x of t is going to equal, the one ordered pair I know is 0, 5. That means this is going to be 5, and I'm going to integrate from 0 to t. My integrand is supposed to be the derivative that I want. So here's my integrand. The derivative I want is sine of t squared. The only rule is I can't write it with the letter t, because t is already my upper limit. I can't write it with an x, because x is already the name of my function. So I'm going to write sine of p squared dp. All right, so now that I have taken care of the 9th graders who are messing around with my heater, I can finish this video and say that I've now written a function for position, x of t, and I've been asked to find the position at time 3. So I need x of 3. I can write x of 3 equals 5 plus the integral from 0 to 3 of sine of p squared dp. I'm going to type that into my calculator and find a final answer. There we go. Clear out the last one. Let's do this. There we go. This is going to be 5 plus the integral from 0 to 3 of sine of x squared dx. And then hit enter. And I'm going to know the position of the particle is, I'm going to label my answer too, so I'm going to write x of 3 equals 5.773. Notice the 4th decimal place is a 5, so if you round it up to 5.774, that gets credit to